So today we are going to start on compounds as well as to talk something about mixtures also. First thing you must know, everyone, definition for compounds is very important. You will be asked, a lot of students will be thinking that, so easy, I think I can remember. So what they do is they will forget about, memorizing definitions. What is an element? What is a compound? What is a mixture? They will definitely forget to memorize it. If I ask you what is the definition for compound, this is the expected answer. I think it came out in your worksheet also. Okay. So you need to say, this compound of a substance contains two or more elements chemically combined together. Elements, last week we learned, it's the most basic, right? The most basic building blocks, okay, of all matter. So there's a difference between the two. Okay, there are also similarities between the two. We will explore later. Now, compounds have different properties from the elements that they are made of. An example here is water. Okay, water is made from hydrogen gas and oxygen gas. All right. So if you look at the equation, okay, the equation is like this. All right. Then the word equation, hydrogen plus oxygen gives you water. So, okay, if I were to draw out, okay, water has a Mickey Mouse shape. Those of you in my class last year, I would have also shown you, okay, water is a Mickey Mouse shape made up of two hydrogen atoms and one oxygen atom. If I talk about just a hydrogen gas look like this. Okay. Okay, so H2, right? Looks like this. This is hydrogen gas. Oxygen gas, okay, so definitely it will be O and O. So this is oxygen gas. This is how they are bonded. Okay, so one oxygen molecule is made of two oxygen atoms. You know that oxygen gas is in our atmosphere. Can you see it? No. Can you smell it? No. So there is no color to it. We can't see it. There's no smell to it. So it's a colorless gas, but it is around us. Okay. There's a 2 in front, right? Good question lah. You see, if I want to combine these to form water, Tammy, okay, you see this, there's only one oxygen, okay, with two hydrogen, right? So 2 hydrogen and 1 oxygen. There's 1 oxygen extra leh. I can't throw that oxygen away, I can't say, I want to make my water. So hydrogen come, oxygen come, okay, got extra oxygen, bye-bye, throw you away. Cannot. You have to make sure that oxygen is also being used in the reaction. That's why, okay, I got extra, right, oxygen. So I'll be asking, can more hydrogen gas come in or not? Then I can make a bit more water. So oxygen say, okay lah, I ask my friend to come. Okay, so another hydrogen molecule comes in. So now I have another 2 hydrogen, right? Can combine with this oxygen or not? Can. So I have 1 more water molecule. So I try to make sure everything is used that I don't throw away. Cannot. It will not be possible, which is why you see a 2 here and a 2 here. Okay, Tammy? Yeah, because I cannot abandon another oxygen. So I ask more friends to come in, then I get more water. Yes. I'm a bit confused at the extra hydrogen part. Oh, okay. Now, it's like baking law, Nikki. When we want to make, let's say, cakes, right? Let's say I have a lot of the ingredients, for example, flour. Okay, flour. Flour, I got a lot. But today I got 2 eggs. If I follow my recipe, 1 cup of flour goes with 1 egg, then some butter, okay, maybe 1 tiny block of butter, okay, and then 1 block of sugar, maybe sugar cubes to make 1 small cake. But I want to make sure I want to use up all the eggs I have. So if I want to use more eggs, I must use more flour, right? Yes or not? Yeah, lor. So baking is an example of chemical reaction also. There is a standard recipe to follow. Okay? Yes, Nikki.
Does that mean the hydrogen substitute the one oxygen that is left?
Not substitute, but react with.
React.
Don't worry, these questions that Tammy asked, okay, you will not learn at this level. You only learn in secondary 3. It's called balancing equation, which is not required at Sec 1 level. I'm answering her so that she knows what is happening here. How come got a number there? Okay, hydrogen is always just H2. She asked me, why is it H2 and not 2H2? Okay, I don't want her to think that the 2 in front is part of the formula. No, it's only for balancing equation. Oxygen gas has a formula O2 and water is H2O. So whatever number in front of it is not what you need to know at your level. Is that okay? Can everybody understand this part, right? Good. Okay, so this is crucial. Okay, what you need to know is water is a colorless liquid. Can we see water? Yes, we can. Okay, can because it's in liquid state, ma. I put this better. So when you have a glass of water, like this water bottle has a lot of water inside. Can see, right? Yeah, can see the water, right? Can we see oxygen gas? No. Can we see hydrogen gas? No. Okay, and another thing you must know also, okay, oxygen supports burning. All right. Hydrogen is explosive. Okay. Is water able to burn? Is water able to explode on its own? No. So do you see now? Compounds have different properties from their elements. Hydrogen and oxygen, they have their own characteristics. Water is very different also. Just like your dad and your mom give birth to you. Okay? 2 person give birth to you, Tammy. Are you the same as your dad or the same as your mom? No, right? You are your own special person, isn't it? Okay? So this is the meaning. All I want to tell you is, okay, water being a compound is very different from the elements it is made up of, which is hydrogen and oxygen. Okay? Yeah. Don't copy anything. I will give you all these slides. Did you all get the slides last week? Never, huh? Last lesson, did you all get the slides? The notes part? No, I will give it to you later. Okay, so the element slides as well as the compounds mixture slides, I will give all to you. Don't rush to copy. I know some of you are like Jensen is copying and copying. Okay, faster copy, she's going to go on to the next slide. I know you're doing that. Jensen, don't worry, I'll give it to you. Can? So when you go another level, you're going to even learn about the bond angle. Not necessary for you now. Please don't go and ask me this question. Mistake. Will they test me that the angle is actually 104.5? No, but this is the correct information. Okay, when you go to should be JC level, you will be starting to learn this as well as university level. All right, so I did degree in chemistry and my degree in mathematics also. So yeah, I know what is being covered. So at your level is in fact quite simple, not that difficult. Now, everybody must know that compounds can be represented by a chemical formula, which I showed you just now. Like chemical formula for water is H2O. Chemical formula for hydrogen is actually H2, okay, hydrogen gas, and then oxygen is O2. So these are chemical formulas. Clear? Then you can even find out something about the compound from the chemical formula. You can see how many and type of atoms there are in a compound. So just now I said H2O, right? H2O, which is water. It has 2 hydrogen, okay, and 1 oxygen. Clear? So this is what they are trying to tell you also. Okay, so chemical formula is very, very useful because it gives us information. What are the elements in that compound and how many of each element there are. Okay, so if I were to ask you now, right? Okay, these are the compounds here. I give you the chemical formula. Hey, you all know how to read periodic table already? Yes or no? Last week, I think you learned, right? Wait, so have you learned periodic table before? Not really, you haven't learned. Okay. No worries, let me guide you all along. So I need to share the periodic table. Okay, maybe I can go back to this slide here. Okay, there are some annotation here because last Wednesday I was teaching the group. That group of students was Sec 1 on Wednesday. Okay, so I annotated here and there. Jensen says that's in my 1B book. 1A book also have the last page. You have a periodic table there. Yeah. Okay, so if you can pull out your textbook, that will be wonderful. If you, never mind, I'll be very nice here. I'm going to give you a periodic table. Okay, so you can also print it out. It's a very nice periodic table. Okay, can you see inside the chat? I have sent a PDF copy of the periodic table to you. Okay, that will be very useful. Print it out. I do that for my own children also. Okay, I print out. I even laminate for them. Then they can paste it somewhere at their study desk. Okay, now let me go through with you. This is the periodic table of elements. There are so many elements there. So how are they being arranged? Okay, one information here. Do you see hydrogen has a 1 at the top? Okay, so this hydrogen over here is a symbol. The full name is under the symbol. You have a number at the top, a number at the bottom. Okay, so the number at the top, look at the key. It says proton number. At the bottom is the relative atomic mass. So it's like the mass of that atom lah. Okay, so if I were to refer you to the number at the top, okay, and you move towards the right side, do you see a 2 here for helium? Next row or the next period, you see 3, and then 4, and then 5, 6, 7, 8, 9, 10. So they actually arrange in that manner. Okay, this is one way. And how come they are also classified under certain groups? Okay, can you see the group number I highlighted in yellow? 1, 2, 3, 4, all the way to 18. These are the group numbers. Okay, so period is actually the horizontal row. There's a 1, 2, 3, 4, 5, 6, 7 that I've written here. Can you see? Over here, the vertical one. So this is period 1. I just drew a line across. This is period 1. This is, oops, not so nice. Wait. This is period 2. Okay, and then this is period 3. Okay, all the way until the last one at the bottom, this is period 7. Okay, so periodic table, these are called the periods. Then group number will be, let me show you using another color. Okay, so let me choose purple. So all these elements vertically downwards, we call these the group 1 elements. Okay, so these will be group 2, all the way until the last one. The last one over here is group 18. So all these elements are found in group 18. Okay, so this is what the